as you understand, Fronius is a European company. Basically, it started in the year 1945 in Austria. Austria is a small country very close to Germany, and founder was Mr. Gunther Fronius, who started this organization or the company from a very, you can say, humble beginning in the during the World War, just post World War 1945. So he started with some scraps, building equipments which can give life to the batteries. So it was basically a battery charger. So from that beginning, 1950, he diverted his business towards welding technology. With the start of initially it was like a welding rectifiers. Then gradually the technology evolved, and 1980s, Fronius introduced the primary switched kind of inverter, and similarly as the decades passed on, like in 1990s, the digital or microprocessor based equipment started coming in. So in 1998, Fronius introduced a range of digital inverters, like microprocessor controlled equipments. And I must say that is the time India also joined hands with Fronius. Like it was like not Fronius India, definitely it was another very well-known company, that is Larsen and Toubro, who was the distributor for Fronius. So 1998 onwards till 2013, and then 2013 Fronius India entity came into picture when Fronius started the subsidiary. So during this period, 2013-14 onwards, Fronius jumped to the next level, fourth generation, what we call AI-based platform. So basically, these equipments are called intelligent equipments. So this way, the technology kept on evolving. In between, Fronius introduced some revolutionary technologies like CMT, that is cold metal transfer, which is again widely used in stainless steel applications. I will come maybe in the some cases I can mention of some special applications. So this is the way gradually Fronius was kept on innovating various processes. So the backbone of all these are basically our strong and vibrant research and development team. As on today, we can say around 800 engineers and scientists. They are working to bring newer technologies which can either make us more sustainable and also resolve various challenges. What usually are considered as a myth that these are going to come. So Fronius is not ready to accept that. So one of our old tagline was decoding the DNA of the art. So when we decode the DNA, that means we can recode and create without the genetic things. So that is the way we can say. So that is one of the philosophy, and that's what our R&D scientists and engineers, they are doing, continuously developing newer process, newer technologies, and which are helping the fabrication and welding industry as a whole. Actually, stainless steel, as you know, it's a very dominant alloy metal in the industry. Because I'm also a metallurgist, I can say that what are the benefits of stainless steel. But on this platform, maybe I share more on like what are the applications of stainless steel. Nowadays, we find stainless steel applications other than household, which is we all know household appliances and all. Apart from that, we see the trains to maybe the infrastructure projects, and also we say for the commercial transportation. Everywhere we are finding applications of usage of stainless steel, because it is becoming day by day more and more relevant for a longer life period for the products or components what we manufacture. And India being a country with varying kind of a atmosphere, the corrosion is one of the biggest challenge. And apart from that, there are applications like chemical, fertilizer, petrochemicals. There are so many different pipelines everywhere. Stainless steel is something which gives a very longer life. And as we are in the industry, we know that any metal or any alloy, until unless it is welded, it cannot be utilized. From the plant, what we get in the form of sheet metal or in the form of various bars and wires, but it must be joined together to form a component. or an equipment. So welding is one of the integral or inherent part of stainless steel development in each and every country, I can say. And stainless steel is very sensitive to heat and certain situations. So welding becomes very, very critical. And there we play a vital role in giving the technology to the industry. So if we talk about metro coaches, which is one of the very high demanding and very high prospect future, I can say. Every small city, small towns will have metros, and metros are usually made by stainless steel. Though aluminium is picking up, but due to the maybe the cost of the basic material, still it is not getting that place in this race. So stainless steel is marching much ahead of aluminium. So here we find that very thin materials to be welded, that too for a very longer length of 22 meter or 25 meter coaches without distortion. It should have a good look, as well as it is carrying human being. So safety is one of the major criteria. So welding takes a very strong position here, because this is something can make us safe as well as proud by giving a very good aesthetics, which is normal steel can give a strength and safety, but aesthetics is always a question mark because of the climate. So stainless steel gives a combination of both. We get a good aesthetics as well as a safety security. So here Fronius has introduced, like if I come to our role in this, that we have developed, Fronius has developed certain certain technologies and welding processes. As I mentioned in my previous question or previous answer, that CMT is basically a short form of a cold metal transfer. This is a patented technology, came into picture or came into industry or in the market by 2004-5. So it is almost 20 years. Still, it is running very strongly in every industry. So when we talk about railway coaches or any component which is experiencing thermal cycling and also distortion to be controlled, and corrosion resistance should not get affected. So all these situations we have a solution in the form of CMT, which gives very low heat input, which is one of the criteria for joining of stainless steel, because stainless steel is very sensitive. More heat will deplete the chromium layer. So chromium is the alloy which makes the stainless steel. That stainless property comes from the chromium. If more heat is there, then chromium will deplete and the alloy will lose its main property of corrosion resistance. So here, this is one of the technology. Apart from that, we have various other processes, technologies like plasma welding technique, and also we have the keyhole tick process, which all are used for cryogenic applications for making the cryogenic tanks. Cryogenic means basically the liquid oxygen, nitrogen, these gases, when they are in a very negative temperature, maybe minus 186 degree, minus 192 degrees are their boiling points. So these gases are stored in certain equipments made from stainless steel because of its inherent property. And further, chemical resistance like duplex steel is another area which is picking up in the industry, and since many years it is being used in petrochemical and fertilizer industries for the duplex. Now, so these are the areas we have a specific alloy-wise database. Like there can be various equipments with used for stainless steel welding, but here we have welding equipments with database for each and every grade. Be it austerity grade, maybe 316L grade. So there is a specific welding database or welding program selected for that particular alloy, which is different than maybe a martensite grade or a ferrite grade. So equipments are having detailed database. So our R&D and our team has developed specific welding programs for specific stainless steel, so that we are not compromising on any generic, using a generic parameter or generic program. So these are few steps we have in our equipments. Hope that is keeping us away or ahead of the technologies, and this is being very much used in the industry. It's very nice to hear the TIC dynamic, because this is something Fronius has introduced, and it is an innovative process which is again being patented. So far in the industry, TIC was always considered, or TIC is still considered, one of the cleanest process, but it is very highly skill based process. Like operator needs to be very highly skilled, and these skills are for manual process, because in the manual welding we need a skill of a person. So here the person can view, and he with his skill he can control the feeding of the wire. But as the industry gradually are shifting towards automation, semi-automation, because they need to produce more, they cannot depend on only limited human skills or limited availability of high skilled operators. So this is the innovation which will actually make the application or the fabrication industry less dependent on high skilled TIG operator. TIG is a TIG process, tungsten inert gas welding. So this is in high demand. So these TIG operators, what the skill they do by viewing by their eyes and controlling with their hand, the same intelligence or same artificial intelligence is fed in the system. Now the wire feeding is controlled by the machine equipment. So it is a kind of a self-regulating wire feeding. So whenever a person is doing welding, even if he is not that skilled, but the wire is synchronized with the welding parameter, and during the operation whatever dynamism comes into picture because of his hand movement or skill shortage, the wire movement will be adjusted automatically. So that's why it is called dynamic wire. It is not a static wire. So dynamism brings in independence from the dependency of the skilled person, as well as it increases productivity, it reduces defects, and definitely it makes it is future ready for automation. In automation, we have these challenges of that human touch was missing when used to do automation, that human eye contact or touch. So with this AI, or a kind of a AI, we call it a TIC dynamic. That is our terminology. We are bringing the same features or benefits to the welding process. So that's how it is going to be. Definitely next decades it will revolutionize the TIG welding operations. Yeah, we one of the, we have various pillars of our values. One of the major value out of these values is sustainability. So that is Fronius philosophy, is that whatever we do, it should not damage or harm our mother earth. So in our day-to-day operations and every manufacturing, even day-to-day usage, we are very, very conscious to do it sustainably. I will give few examples. Like all our manufacturing plants and offices are powered by solar energy. And so even in India, the Fronius India headquarters in Pune is 100% green powered. We have 150 kilowatt rooftop solar plant, and it is making us self-sufficient. We are not dependent on the grid or fossil fuel based power. So we proudly display how much green energy we are consuming or how much CO2 we are saving. And we also display that there is a algorithm through which we calculate that this much of CO2, tonnage of CO2 means how many plants. So we proudly say that this many plants we have saved in other way, or this many plants we have planted. We can say, when we say this much of CO2 we have reduced from the atmosphere or environment. This is one part. Another way, Fronius also has a business. When we talk about the energy solution, one of the major business is our solar energy business. Under this solar energy umbrella, we are the manufacturer for solar inverters. These inverters are the basically kind of brain or heart for the complete solar system. Solar energy part, where the PV cells, PV is the photovoltaic cells, they actually create the DC power. These inverters convert it into from DC to AC, and that AC is given to the grid or to the usage. So that is what we are involved. So that was the idea of maybe Fronius, that one way we are doing welding, where there will be smoke and heat. Other business should take care of the sustainability part. So this is one way we are trying to balance, and we are giving back to the Mother Earth, that we are reducing carbon footprints by utilizing this. Also in our manufacturing, we use all recycled material, like all the heat sinks is one of the part of our welding equipment, or any equipment where heat is generated during operations. So heat sinks all are aluminum based. So we use always recycled aluminum for these parts, because aluminum manufacturing itself is a very high energy consuming process. So where this recycling reduces the carbon footprint to the earth. Apart from that, we have stopped all kinds of packing material which are not biodegradable. So we have installed our equipments even in Fronius India headquarters in Pune, wherever our warehouse team, they make some packings, they always use recycled paper and recycled material for packing. So this way we are trying to reduce the harm to the earth. Challenges, definitely there are. One challenge, big challenge in the industry is very changing technology. Technology is changing very rapidly. If we talk about automobile industry, we see that every automobile car manufacturer wants to reduce the weight of the car, but increase the safety of the car. Also, fuel mileage economy should be better. So what is changing is basically the design or the construction and the material. Earlier, the material was more of a thick material. Now they are reducing to a thin material, but with high strength. So when we metallurgically, we call it that ultra high strength steels are coming into picture, and many of the time these steels are having high alloys. So when it becomes high alloys, it is not always easy to weld. So welding is becoming more and more challenging. Hope I am making the sense where I am trying to come. Okay, so this is one of the challenge, but we accept the challenge, and we also develop welding processes, new database, new programs to fulfill the requirements or demands of the industry. So whenever there is a new car or new material coming, our team on the back end, they also start doing research and doing practices development, that how we can be at par and we can give a solution for this particular challenging material. So that is one way we are resolving. Another way is every industry is looking for higher productivity. Earlier it was like a manual, now everybody wants to do automation by robotics and automation. Robotics and automation are becoming common for every industry. Earlier it was only limited to certain industries like automobile industries, but now even medium scale MSMEs are going for robotics and automation because there is a huge shortage of the skills. So in this sector, it is the general, I will not say it is for only stainless steel, but one challenge is definitely the quality of input material. Suppose stainless steel is coming from the mill, and there is no straightness, or the cutting or the rolling is not proper, so there are always warpages. So when customer is looking for automation is always expects that it should be perfect fitment, and then it can give its output. But if the fitments are not proper, so welding becomes more challenging, more defects, more rework, which many times the users will not prefer. So these are some things. Apart from that, definitely there is a matter related to finance and economics, because automation is going to be expensive. So there is more investment, and they need to do more so that the return on investment is easier. So these are few challenges. Apart from that, I definitely take mention about the skill shortage. that every industry is not, or every application cannot be automated. There are various infrastructure projects and various other areas where manual, but nobody wants to come. Or that day by day, the people's inclination towards welding industry or metal industry are reducing. So we are finding that young generations are not much interested to come to these fields because everybody wants to do a better, or maybe from blue collar to white collar and something different. So that is a bigger challenge and biggest challenge to the industry, not only in welding field, I think in each and every field, mostly in the hard engineering industry, that skilled operator availability. So I can mention that, okay, we are also doing something. Maybe in a short, I can say that Fronius is running something. We call it a program, which we are trying to give it back to the welding fraternity. So Fronius India, as a Fronius India, we connect with the ITIs, and so welding trade young boys we are picking up and selecting them based on their desire to work in this field, and we are giving them advanced training free of cost, so that they get more interest into coming and remaining in this field. And also we help them to get employed. So we provide them employment assistance, because we have a large base of our users and industries who are actually looking for trained personnel. So we connect with them. We say that we have these people trained by us. If you wish to take them, please. So that way we are trying to bring a new, fresh, young people into this industry. So that is, we call it a FACT program. This program name is FACT. It's an abbreviation, Fronius and Academia Center for Technical Training. So FACT is running well. We have done already 7 batches. Because of our limited infrastructure, we cannot take a large batch. We have a dedicated team. They normally per batch is 24, 25 boys, including girls. We did some dedicated 2 batches of girl students, and they all got good employment in the nearby industry. They're very happy. I think it is kind of a women empowerment as well. We can say that they are able to get their family support. They are able to give back to support to their families and lead their life at their own way. So this is how we are trying to give it back in the industry. So these are few challenges and some resolutions or some solutions we are trying to provide. Very nice question, because now every session I feel this is the trend, and that should be there, that what is there next. So everybody wants to know what is next. Like other advancing industries and sectors, welding is also, I already talked about the challenges. So next thing, or already it has come, is AI. We all know that artificial intelligence or Internet of Things. So Fronius already, we have a strong software team who are actually working at the back end to support this. So we have smart managers we have developed. So smart managers, basically these are connected with the welding power sources, and these can be connected across the plant. Suppose in a manufacturing plant there are several welding machines, and the manager sitting in one place, he can connect all the machines, he can have a review, and even if nobody reviews, the data will be consolidated and analyzed, and it will give a clear picture about which are the areas there could have been a mistake, or there may be a fault. If a fault is found, then analysis will be easier and corrective measures can be taken. So these kind of smart managers are going to be in all the industries. Already it has started with some very advanced industries, though it is in discussion, but not everybody has started, because it needs some kind of investment also. Old outdated equipments will go obsolete, and they have to bring in new fresh technology based, so that you can utilize, like in mobile, we can say, just give an example, If we have a smartphone, then we can do so many things. If smartphone is not there, we cannot do. So industry, sometimes people are talking, but they are not ready to shed off their old equipments. So that is one challenge, I can say. Gradually it will shift. So already some industries, like I know the GE and all these advanced industries, they have started implementing these AI based things, so that all the data are analyzed and it can be monitored. And also another thing is coming very fast is additive manufacturing. Like fabrication earlier was like either it is to be joining or it is subtractive. Like a component to be made from a metal bar or metal block, then material has to be removed. So there were a lot of material losses, and it takes longer time and cost. Whereas 3D printing is additive, is basically metal 3D printing, where by use of wires or powders, metal can be deposited as per the desired shape and profile. So that is picking up very fast. I know there are many research organizations and some manufacturing industry has already started manufacturing. Not in India, but we can say in advanced countries, it has already we can say it is productionized. Already the productions are started. In India, it is at the stage of maybe research, development and analysis, and people are already started taking this kind of projects, so that some components are developed out of 3D printing, which is much cheaper. It is, we can say, 75% cheaper than fabrication or machining subtractive process. So that is definitely going to revolutionize or shake the entire industry when that kind of technology comes in. And Internet of Things already spoke. So all these will be a combination which is going to be the trend of the upcoming years.